Hello, Math 1 students. This is section 12.4, Isosceles and Equilateral Triangles. We're actually cutting out quite a bit from this section, just basically narrowing it down to what you really need to know for this class and for next year and the year after. So we're going to learn the base angles theorem, and we're going to use isosceles and equilateral triangles. So as a matter of review, a triangle is isosceles when it has at least two congruent sides. Now, we're going to be learning some vocabulary when it comes to isosceles triangles, so if you need to write them down or circle them in your notes, go ahead and do that. When an isosceles triangle has exactly two congruent sides, these two sides are called the legs. So the legs of an isosceles triangle are the two sides that are congruent. They could be long, they could be short, they're just called the legs. Now the angle formed by the legs is called the vertex angle. Now normally when you see an isosceles triangle, they're drawn in such a way that the two legs are side by side and the vertex angle is at the top. So that is the vertex angle. The third side of the isosceles triangle is called the base. So this down here is called the base of an isosceles triangle. Okay? To go along with that, the two angles adjacent to the base are called the base angles. So the base angles are the two angles that touch the base. And usually when you look at an isosceles triangle drawn out, they're the two angles at the bottom. Now the base angles theorem is very important. The two sides of a triangle are congruent, then the angles opposite them are also congruent. So what that means is if you have an isosceles triangle where the legs are congruent, in this case AB is congruent to AC, then angle B is congruent to angle C. Notice that the base angles are now congruent. So this is why it's called the base angles theorem. If you have an isosceles triangle, the base angles are congruent. Now the converse of the base angles theorem says, if the two angles of a triangle are congruent, then the sides opposite them are also congruent. So if if angle B and angle C are congruent, so the base angle is congruent, then the two legs have to also be congruent. AB is congruent to AC. Now, what does it mean when we see opposite? The angle opposite, the side opposite C is AB. The side opposite angle B is AC. So a side opposite the angle is the side that the angle is looking out towards. 1A, in triangle DEF, DE is congruent to DF. Name two congruent angles. So you have two sides of a triangle are congruent. So that's an isosceles triangle. Now if you imagine turning this triangle up so that angle D is at the top, the two base angles are angles E and F. The two angles that are touching the base of the isosceles triangle, so angles E and F are congruent. 1B, in triangle ABC, angle A is congruent to angle B. Name two congruent sides. So now you're going to use the converse of the theorem. The sides opposite the two congruent angles are congruent. So you have AC and BC are congruent. 1C, complete each statement. If HG is congruent to HK, so now as you notice we're looking at this triangle there, which two angles are congruent? Well, that's going to be angle G and angle HKG. So angle G is congruent to angle HKG. Now we're going to look at the bigger triangle. If angle KHJ is congruent to angle J, now we're looking at this triangle here, and notice the two base angles are angles KHJ and J, which means these two sides are congruent. So HK is congruent to JK. So it's an isosceles triangle, and the base is the one that's facing up and to the right. The corollary of the base angles theorem says if a triangle is equilateral, then it is also equiangular. So if all three sides are congruent, then all three angles are also congruent. And this is the corollary to the converse. If a triangle is equiangular, then it is equilateral, which means if all three angles of a triangle are congruent to each other, then the three sides are also congruent to each other. Example 2A, find the measures of angles P, Q, and R. So notice that all three sides of the triangle are congruent. So this is an equilateral triangle. Since all three sides are congruent, then all three angles have to be congruent. Since all three angles have to add to 180 and they're all the same, you just divide 180 by 3 and the measure of each angle is exactly 60 degrees. 2b, find the value of x. So notice again we have an equilateral triangle, which means all the angles are 60 degrees. So that means 2x has to equal 60 because the measure of angle r is 60 degrees. Divide both sides by 2, and you see that x is equal to 30. So equilateral triangles and equiangular triangles are basically the same triangle. Each angle is exactly 60 degrees. 3a, find the values of x and y in the diagram. So what we have are an equilateral triangle and an isosceles triangle. So let's start with the equilateral triangle up here. So you can see it's equilateral because all three angles are congruent. And the rule is if all three angles are congruent, then all three sides are also congruent, which means since KL is equal to 4, that means KN has to also equal 4, which means y is 4. Next, we're going to solve for x. Now we're going to be looking at this triangle down here, triangle LNM. Now notice it's an isosceles triangle because the two base angles, angles LNM and angle M, are congruent. So the two legs are congruent. Now, how do we know what LN is? Well, we know that LN has to be the same length as LK because it's an equilateral triangle. And since LN is 4, and Ln has to equal Lm, that means x plus 1 has to equal 4, or x is equal to 3. Finally, example 3b, find the values of x and y. So let's start with the equilateral triangle, or the equiangular triangle, which means it's also equilateral. So the sides have to be equal, which means 4y has to equal 28, which means y is equal to 7. Now we're going to look at the other triangle to solve for x. Now this one's a little trickier. First of all, you have to see that this also has to be 28 because it's an equilateral triangle on the right. So that's 28. Now notice that this triangle here is an isosceles triangle because the two legs are both 28 units. Now we need to first figure out the measure of the vertex angle, which I will mark here in blue. What is the measure of that angle? Well, we know that this is 60 degrees right there because it's an equilateral triangle. So this other angle, the vertex angle of the top isosceles triangle, has to be 180 minus 60, or 120 degrees. So if that's 120, the two base angles, which I will mark in purple, have to be congruent, and they had to account for the other 60 degrees of the triangle. 180 degrees minus 120 is 60. Since each angle is equal, each angle is 60 divided by 2, or 30 degrees, which means this angle here, 2x, has to equal 30, and x is equal to 15. That's it for section 12.4. We're going to get back into congruence triangles beginning with section 12.5.